Hello guys, welcome to the Harvard Lab today. My name is Babatunde and today we're going to be talking about scientific notation with negative exponents. Okay, so what this means is we're going to be dealing with exponents. Exponents basically means powers. Okay, so if you see something like 5 raised to the power 3, this 3 here is the exponent. Okay, and so based on this question, the exponent here should be minus 4, right? Because minus 4 is the power, right? So let's work with that. Okay, so whenever we have, because we're going to be dealing with negative exponents, right? So whenever we have negative exponents, it's always advisable to find the reciprocal of that number. Okay, so basically what reciprocal means is, let's say for example, we have 10 to the power minus 2. Okay, I'm using an example here. This is the same thing as 1 over 10 to the power 2. Okay, and we're doing this to remove the negative part of the exponent. Okay, so we want the negative to be a positive. And now to do that, we have to find the reciprocal. And the reciprocal basically means we're going to put whatever is at the bottom and take it to the top. And whatever is at the top, we're going to take it to the bottom. Okay, so in this case, even though we're not given that 10, there's a 1 on the bottom of 10, we automatically know that there's a 1 at the bottom of 10. Because anytime we see a normal number like 5 or 6 or any variable or y or something, okay, if you see them like this without any denominator, let's say if 5 had 5 divided by 2, then we can say okay, yeah. But if we see any number like this on their own without any denominator or anything at the bottom, we automatically know that that's divided by 1. Okay, so we automatically know that this was a divided by 1. That's why we put a 1 here at the top and then a 10 squared at the bottom. Okay, so that's the same thing we're going to do here. We're going to work with this question like the way I put it in here. Okay, so basically based on what I said, this is the same thing as 8.65 times 10 to the power minus 4. Okay, and minus 4, since the exponent here is a minus, we have to do what we did here. Okay, so this is 10 to the power minus 4. Okay, and this is the same thing as 10 to the power minus 4 over 1. Okay, based on this. Okay, and so in order to remove this negative from here, we have to divide. We have to say 1 over 10 to the power 4, like the way we did over here. So in this case, we put 1 at the top and 10 square at the bottom. Okay, so that's what we're going to do here. So this is 8.65 times 1, because we put 1 at the bottom in this case. So 1 has to go up. Okay, we're basically finding the reciprocal. Okay, so when we put 1 up, we'll put 10 to the power 4 now at the bottom. So this becomes 10 to the power 4. So this minus basically cancelled and becomes a positive value. Okay, so this is 8.65 times 10 to the power 4, which is basically the same thing as 8.65 times 1 over 1 times 10 raised to the power 4. Okay, so this is 8.65 times 1, okay, which is equals to 8.65, right? And then 1 times 10 to the power 4 equals 10 to the power 4. Okay, so now we're good, right? So basically, what is next for us to do is for us to evaluate this as a whole. Okay, and in order to work with this, when we're given this kind of situation, like let's say 10 to the power 4 in this case, this is basically telling us to multiply 10 in 4 places. Okay, that's why it's called an exponent. We'll use this as kind of a counter to multiply the whatever value is holding it. Okay, so in this case the counter will be 4, so we'll have to multiply 10 by itself 4 times. So that'll be 10 times 10 times 10 times 10. Okay, so we'll multiply 10 4 times. So in that case, if you multiply 10 4 times, a simple trick I want to show is whenever you're giving 10, especially 10 to the exponent of whatever, okay, all you have to do is just count the amount of exponents, which in this case is 4, right? And then replace the zeros with 4 zeros. Okay, so in this case it's 10 to the power 4. So all we're going to do is say 1 and then replace the zeros behind 1 with 4 zeros. Okay, so it's going to be 1 2 3 4. Okay, so this is 10,000. Okay, so replace this 0 with 4 zeros now. Okay, and the next step that I want to do is I want to divide this because it has to be in standard notation. Okay, and in order for me to divide this, let me, because I have to make a bigger space. Okay, so in order for me to divide this, what I have to do is every time I cancel out this 0, I want this decimal point to be taken back once. Okay, so whenever because I have to divide these 8.65 to 10,000. Okay, and when I do that, I have to make, because whenever I divide this dot has to go back once. Okay, so as I'm dividing, as I cut this 0 out, this dot has to go back once. But if I'm multiplying, right, so let's say for example I was multiplying 5.2 times 10 times 10, right? This dot has to go forward in this case because I'm multiplying, right? But since I'm dividing, this dot is going backward. Okay, so let me put that into practice. 8.65. So what I want to do here is I want to cancel every 0 I take. So every time I cancel a 0, this dot has to go back once. Okay, so I cancel the 0, the dot goes back once, right? So now the dot is right here. So when I cancel this first 0, the dot becomes right here, right? So this is basically saying 0.865. Okay, so I have to cancel out the next 0 because I have to do this until the zeros out here are cancelled. Okay, so when I cancel the next 0, this comes up here and this creates space for another 0. So add a 0 here, and now the dot is right here. Okay, so now when we do that again, we create another house for the 0. Okay, and now the dot is right here also. Okay, so the same thing again, we're done. This is the last one now. When we cancel again, the dot then comes here, and then there's a 0 here also. Okay, and then finally the dot stays here. Okay, so this is the same thing as 0.000865. Okay, and so when we're doing with this, we want a number in front of the dot. Okay, so since we know that it can't be any other number, it can only be 1 in this case, right? So all we have to do right now, whenever I see a dot like this, is basically equivalent to saying 0.000865. Okay, so whenever I see a number like 0.23, okay, this is the same thing as 0.23. Okay, as long as you put the 0 in front of the decimal point, it's good. Okay, so in this case, we have the dots here. Okay, but we don't have any number here, so you can automatically put a 0 in the front. It doesn't really matter. Okay, so let's check that. 0.000865. It's 4 zeros. Okay, all right, so let's look at more practice. Okay, you can feel free to pause the video if you want to kind of test your knowledge. I really support that. Okay, so this is telling us to write 0.0006631 in scientific notation. Okay, so we're gonna basically use the same approach that we used in the other question that we just worked on. Okay, and if you notice, there are zeros in front of the numbers, right? Okay, so whenever you see like there are zeros in front of a number, just make that exponent. The exponent we're going to be working with is going to be a negative. Okay, so say for example, we have 5 divided by 10 to the, or let's say we have 5 times 10 to the power minus 2. Okay, this is basically saying 5 times 1 over 10 squared, which would be equals to 0.05. Okay, the zeros are in front of the 5 in this case, right? So we automatically know that since the zeros are in front of the 5, right, there's a 0 and there's a decimal point here. Okay, we automatically know that the exponent is going to be a negative. Okay, so based on that, we're going to work on this question like that. Okay, so there are zeros here in front of these numbers. Okay, but we don't basically know what the exponent itself is, but we know that since there are zeros and there's a decimal, this is going to be a negative exponent. We're going to be working with negative exponent. Okay, so one trick I want to say, I want to tell you is that whenever you're given a number like this, what you want to do is you want to count the amount of zeros that are in front of the numbers. Okay, so the amount of zeros in front of this number is 1. You have to count the 1 even after the decimal point. Okay, so this is a 0, 1, 2, 3, 4, right? So we have 4 zeros. Okay, so we know we have to divide 6.631 by 10 to the power 4. Okay, I'm getting there. I'm getting there. Okay, so let's just stay in this. We know we have 4 zeros. Okay, so automatically we can say this is going to be dealing with 10 to the power minus 4. Okay, because we know the exponent was a negative since there was a 0 in the front, but we didn't know what the exponent itself was. And in order for us to find what that exponent is, all we have to do is to count the amount of zeros in front of the number. Okay, so the amount of zeros in front of this number was 1, 2, 3, 4, right? So since it's 4 and we know the exponent is negative, all we do is just say negative 4 because we know that there are zeros in front of the actual number. Okay, so this is a negative 4. Okay, so the next thing is to figure out how we're going to put it in scientific notation. This is 6631, right? The numbers here are 6631. So it's always advisable whenever you're working with scientific notation to put in one number in front of the decimal point. Okay, so say for example we have okay, let's use this one. This is 6631, right? So basically this is basically saying what I basically mean is that I want to put the first number, which is 6 in this case, in front of the decimal point. Okay, so this is the decimal point. I want to put this 6 in front of the decimal point and put whatever number that I have left, okay, this 631 behind the decimal point. Okay, so basically what this means is saying 6.631 times 10 to the power minus 4. Okay, so what I basically did was the first step I counted the amount of zeros in front of 6631. Okay, so when I did that, that was equals to a 4, right? And we know that since there were zeros in front of the numbers, that was a negative. Okay, the exponent would be a negative. Okay, so basically the exponent turned into a negative 4. Okay, so that was settled out. We know this was a 10 to the power minus 4, right? Because we're dealing with tens in this case. Okay, so to find this to work with this 6631, we're basically going to be, because basically this means this 6631 behind these zeros basically means 6.631 times 10 to the power minus 4. Okay, basically if you multiply this by 10 to the power 4, it's going to give you the same thing, 6.631. Okay, so matter of fact, let me work on that. So this is 0.0006631, right? So we know the amount of zeros here are 4, right? And we want to shift this dot to the possible to the front of this normal numbers, right? And now for us to do that, we have to multiply by by 10 to positive 4 exponents in this case. Okay, so that would be times 10 to the power 4, right? And remember, when we're multiplying by 10 to the power anything, we always bring the decimal points forward. Okay, so 10 to the power 4 is basically saying 1 and then 4 zeros behind. 1, 2, 3, 4. Okay, so basically this means 0.0006631 times 1 with 4 zeros behind. Okay, so we cancel this dot comes forward, cancel this dot comes forward, cancel this dot comes forward, cancel this dot comes forward. Okay, so what we're left with now is 6.631. Okay, so that's another way of finding what to put in front here. You can multiply it by the positive part of the power you have. So in this case, the negative one was negative 4, right? And so I multiplied it by 10 to the power 4, so I can bring the decimal point to 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 the normal digit side. Okay, so when I bought it here, it turned into 6.631. Okay, so this is 6.631, and then I can now say times 10 to the power minus 4. Okay, because when I work with this, if I work with this again, this is going to give me the same thing that was given over here. So if I say 6.631 times 10 to the minus 4, if you plug that in your calculator or you work on it, it's going to give you this same thing. Okay, so that's 6.6331. Yeah. Okay, so thank you very much for watching the video. I really hope it helped you out. Have a beautiful day ahead.